Alright, this is the pre-calc partner test for chapter 9.1 and 9.2. And we're looking at number 1. Number 1 starts by looking at solving the identity. So we don't have any squareds given to us, so our best option is rewriting this in terms of sine and cosines. So we're going to have cosine times cosecant is 1 over sine x minus secant becomes 1 over cosine x. Then we're going to distribute through this cosine x that's on the outside. So we're going to have cosine x over sine x minus cosine x over cosine x, distributing that cosine through to both of these terms. So now we know cosine x over sine x is cotangent x, and cosine x over cosine x cancels out and we have just minus 1. And that is what we were trying to prove. So that one is done. Number 2. Again, we don't have anything being squared. So again, our best option is rewriting these in terms of sine and cosine. So tangent is going to become sine x over cosine x. And then that's all going to be over. Secant becomes 1 over cosine x. And then we're subtracting still that cosine x there. So now we want to get a common denominator on the bottom. So we're going to multiply this cosine x because we can put it over an imaginary 1. We'll multiply this cosine x by cosine x over cosine x. So when we rewrite this, we end up with sine x over cosine x all over. Combining this bottom, we're going to have 1 minus cosine squared x all over cosine x. Then we have a complex fraction. So we can either flip and multiply now, or there is one thing that we can rewrite. This 1 minus cosine squared, that goes back to our very first Pythagorean identity, and that is actually equal to sine squared. So we can rewrite this as sine x over cosine x all over sine squared x over cosine x. So then, since I'm out of room, we're going to move up over here. So now is when we would want to flip and multiply. So we're going to have sine x over cosine x was our top fraction. Then we're going to flip and multiply by our second. So we're going to have cosine x over sine squared x. Now looking at this multiplication, we can cancel out these cosines. We can cancel out this sine with one of those sines. And we're left with 1 over sine x. And 1 over sine x equals cosecant x, which was what we were trying to prove. Number 3. Number 3, again, looking at the terms that were given. We don't have anything being squared, so again, our best strategy is to rewrite all of our terms in terms of sine and cosine. So 1 over secant becomes 1 over cosine x. That's over cosecant, which becomes 1 over sine x. And then we're still adding that to sine x over cosine x. We have a complex fraction as our first term, so we're going to flip and multiply that. So we're going to have 1 over cosine x times sine x over 1 when we flip and multiply that bottom. And then again, we're still adding that sine x over cosine x. When we multiply these two ratios, we end up with sine x over cosine x plus sine x over cosine x. So we end up with sine x over cosine x is tangent x. So we end up with tangent x plus tangent x, which ends up giving us 2 tangent x when we add them together. And that is what we were trying to prove. Number 4 moves into 9.2 and using the addition and subtraction identities. So we're going to start working with this left-hand side because we can expand each of these cosines using the identity. So this first one expands to cosine x cosine y minus sine x sine y. Then we're adding that to the cosine subtraction, which is exactly the same except we switch the sign. So we have cosine x cosine y plus sine x sine y. And sorry about that, I ran out of room. So if we look at each of these terms, we have a negative sine x sine y and we have a positive sine x sine y. So we can actually cancel those out. And we're left with cosine x times cosine y plus cosine x cosine y. When we add those two together, we get to cosine x cosine y, which is what we were trying to prove we could get. Number 5. Number 5 wants us to simplify that expression. So we need to look at that expression and decide which addition or subtraction identity that fits with. So we have cosines together and sines together. So that follows the pattern of our cosine addition and subtraction. So it's going to be one of those two. And then we're looking at, so we know we have a cosine here. And then we're looking at this term, this operation in the middle. We're subtracting. So for cosine, remember that the operations were opposite. So if you have a subtraction in the expanded version, it should be an addition in the condensed version. So we're looking at the cosine addition identity. And then we're looking at the two angles that were given. So we plug in a 10 and a 4. So we get cosine of 14. So cosine of 14 is our final answer. So that's just figuring out which identity this is. Number 6 is doing the same thing, except this time we have sine of 3x minus y times cosine of y plus sine y cosine 3x minus y. So this time we have a sine with a cosine. So that tells us we're looking at our sine identities. We have an addition operation here inside, so that means we're looking at the sine addition. And then we plug in our values for our angles. We have 3x minus y is our first angle, and then y is our second angle. So we have 3x minus y plus y. Our y's cancel out, and we're left with just sine of 3x. So sine of 3x is our final answer. Then going on to the back, number 7. Number 7 wants us to simplify tangent of x minus pi. So we're going to rewrite that using the identity for tangent. That identity said tangent of your first angle minus tangent of your second angle, all divided by 1 plus tangent of your first angle times tangent of your second angle. So now we don't know tangent of x, but we can find tangent of pi. Pi is right here at -1, 0. And tangent is found as x, as y over x. So in this case, our y value is 0 over -1. So tangent of pi equals 0. So we're going to use that fact to simplify this expression. So we still have tangent x minus now 0 over 1 plus tangent x times 0. So when we simplify this, we end up with tangent x over 1, or just tangent x. So our final answer is just tangent x. Number 8, we're simplifying this expression now. And this says sine of pi over 2 plus x. So we're going to expand that out using the sine addition. So that says sine of your first angle times cosine of your second plus sine of your second angle cosine of your first. So now we can find sine of pi over 2 and cosine of pi over 2. Pi over 2 is up here, and that's at 0, 1. Sine, remember, is our y value. Cosine is our x value. So sine of pi over 2 is looking at our y value, which is 1, times that cosine x. Then that's plus sine x times our cosine of pi over 2, which is looking at our x value, which gives us 0. So this side is just going to equal 0, and then we have 1 times cosine x, which just gives us cosine x. Now moving on to number 9. We're asked to use the addition and subtraction identities to find the exact values, and we need to make sure that we rationalize. So we're asked for number 9 to find sine of pi over 12. So we need to figure out two angles that we can add or subtract in order to get pi over 12, and they need to be angles that we know how to find the exact values for. So that's when we look at our pi over 4, our pi over 6, our pi over 3, our pi over 2. And we want to rewrite those in terms of being over 12. So that means that this is 3 pi over 12, pi over 6 is 2 pi over 12, pi over 3 is 4 pi over 12, and pi over 2 is 6 pi over 12. So we can use any of those in order to get that pi over 12. So we're going to do sine of 3 pi over 12 minus 2 pi over 12. So this is taking the sine of pi over 4 minus pi over 6. So if we expand this out, we get sine pi over 4 cosine pi over 6 minus sine pi over 6 cosine pi over 4. So now we're going to use our triangles in order to solve this. So that's our 45-degree triangle is 1 root 2. And our 30, 60, 90, we have 1 root 3 and 2. So sine of a pi over 4 is root 2 over 2. Multiplied by cosine of pi over 6 is root 3 over 2. And then we're subtracting sine of pi over 6, gives us 1/2. And we're multiplying by the cosine of pi over 4, which again is root 2 over 2. When we multiply across, we're going to get root 6 over 4 minus root 2 over 4, which we can combine to equal root 6 minus root 2 all over 4. Then we're going to look at number 10. So you should get root 6 minus root 2 over 4 for number 9. So then number 10, we're given tangent of a 15-degree angle. So for this one, we can use degrees. We don't have to switch to radians. If you want to switch to radians, feel free, but you can stay with the degrees. So out of the angles that we know a 45, we know a 30, we know a 60, we know 90. We want to take two of those and get it to either add or subtract to equal 15. So in this case, we're going to take, and we're going to be taking the tangent of a 45-degree angle minus a 30-degree angle. That'll give us that 15. So expanding this out, we're going to have tangent of 45 minus tangent of 30 all over 1 plus tangent 45 times tangent of 30. So again, we can use our triangles over here. Tangent of a 45 is just 1 minus tangent of a 30 is going to give us root 3 over 3. That's going to be over 1 plus 1 times that root 3 over 3, because we already found those angles up top here. So we end up getting 1 minus root 3 over 3 all over 1 plus root 3 over 3. Now we can't leave our answer like that because we have that radical in the bottom. So we're going to rationalize our denominator, but before we do that, we have these fractions. So to get rid of those fractions, we're going to multiply the top and the bottom by 3. And that's going to get rid of these root 3 over 3's that we have. So we're going to end up getting 3 minus root 3 all over 3 plus root 3. Now we want to rationalize that denominator. In order to rationalize the denominator, we're going to multiply by the conjugate. The conjugate of 3 plus root 3 is 3 minus root 3. So we're going to FOIL this, and we're going to end up, on the top, you're going to end up with 9 minus 6 root 3. And then negative root 3 times negative root 3 becomes plus 3. And then that's all going to be over 9. This is the difference of perfect squares, remember, so you just have to take your firsts, which is 9, times your lasts, which is going to give you positive root 3 times negative root 3 is going to give you minus 3. This then simplifies when you combine like terms on the top. You get 12 minus 6 root 3, and that's all over 6. 9 minus 3 gives you 6. Now you can simplify this further. We can factor out that 6. So 6 goes into 12 2 times. 6 goes into 6 1 time. So it's just 2 minus root 3. make sure that you are simplifying your answers fully. So you end up with 2 minus root 3. For number 11, we're given cosine x equals negative 5 over 13. And then we're told that that angle x is between pi over 2 and pi. Then we're told to evaluate and simplify sine of pi over 6 plus x. This pi over 2, this angle is between pi over 2 and pi. That tells us that we are in the second quadrant. So we know we're in the second quadrant. So we're going to draw an angle over in the second quadrant. That's our angle x over in the second quadrant. So we're told the cosine of that angle is negative 5 over 13. So that tells us that the adjacent side of this triangle is negative 5 and the hypotenuse is 13. So we have negative 5 and 13, our adjacent side and our hypotenuse. Now we need to find that third side. So we're going to use the Pythagorean theorem. We'll call that y. So we're going to have y squared plus negative 5 squared equals 13 squared. Solving for y, we're going to get y squared equals 13 squared is 169. 169 minus 5 squared, which is 25. So 169 minus 25 gives us 144. So y equals 12. So that third side is 12. So now we're going to use that triangle to evaluate and simplify that sine of pi over 6 plus x. So sine of pi over 6 plus x. We're going to expand that out using the identity. So we have sine of our first angle times cosine of our second plus sine of our second angle cosine of our first. So now cosine of a pi over 6 angle is just 1/2. That goes back to using the triangles. Then we're multiplying by cosine of our angle that we found over here. So cosine is adjacent over hypotenuse. So that's going to be multiplied by negative 5 over 13. Then we're adding the sine of that angle. So that's opposite over hypotenuse. So we're going to have 12 over 13. And that's times cosine of a pi over 6, which gives us root 3 over 2. So now we're going to multiply across and then add these. So we're going to end up with negative 5 plus 12 root 3 all over 26. So I just combine that in one step. 1 times negative 5 is our negative 5, plus 12 times root 3 is 12 root 3, all over 13 times 2 gives us 26. And then finally number 12. Number 12 is very similar to number 11, except this time we're given two different angles. So this time we're given that sine x equals negative 3/5, and we're told that that angle is between pi and 3 pi over 2. So if we're between pi and 3 pi over 2, that tells us that we're in the third quadrant. Then we're given tangent of y, so our second angle. The tangent of that angle equals negative 1/2. And then we're told that that angle is between pi over 2 and pi. So that angle, that should say a y here. So that angle is in the second quadrant. And then we're asked to find cosine of x minus y. So before we find cosine of x minus y, cosine of x minus y is what we're going to be finding. I'll write it here. We can expand that. So that's cosine x, cosine y, plus sine x, sine y. So that's ultimately what we're going to have to simplify. To do that, we're going to have to create these two triangles using the information that we're given. So for our x value, for our angle x, we know that it's in the third quadrant. So we're going to draw an angle in the third quadrant. That's our x. We know that the sine is -3/5. So our opposite side over our hypotenuse. Now we need to find that other side. So we're going to use the Pythagorean theorem. X squared plus -3 squared equals 5 squared. So we get x squared equals 25 minus 9 is 16. So x equals 4. Now remember, we're in the third quadrant, so our x values are negative as well as our y values. So we already had a negative y value, but we have to make sure that we make that x value negative as well. So it's -4. So that's labeling our triangle using angle x. Now we need to create a triangle using angle y. So for angle y, we know that we're in the second quadrant, because that's what we're told here, between pi/2 and pi. That tells us we're in the second quadrant. So this is our angle y. We're told that tangent of y equals -1/2. So tangent is opposite over adjacent. So our opposite side is 1. Our adjacent side is that -2. So then again, we need to find that third side, in this case our hypotenuse. So we're going to have 1 squared plus -2 squared equals r squared. That's going to give us that hypotenuse. So we're going to end up with 1 plus 4 equals r squared. So we're going to end up with √5 equals r when we solve for r. So our third side here is √5. So now we're going to use those two triangles to simplify our expression here. So we need to find the cosine of that angle x. So our cosine is adjacent over hypotenuse. So that's -4/5. Multiplied by the cosine of our angle y. So again, adjacent over hypotenuse. So that's -2/√5. We're adding that to the sine of our angle x. So opposite over hypotenuse is -3/5. Times the sine of our y angle is opposite over hypotenuse again. So we have 1/√5. Now multiplying our fractions across, we're going to get -8/5√5.
Positive 8.
Oh, +8, sorry. Because you have a negative times a negative. So positive 8/5√5 plus -3/5 times 1/5. So this positive is actually going to become a negative. And that's going to be 3/5√5. Now we can combine these. We have 8 minus 3/5√5, which we can simplify to 5/5√5. Your 5s are going to cancel out, and you're going to end up with 1/√5. And then do not leave this as your answer. Make sure you rationalize it. When you rationalize it, you're going to multiply by √5/√5, which is going to give you √5/5. So your final answer for number 12 is √5/5. is root 5 over 5. And we're done.